This is VK. Welcome to Smid World. Here I am with another video. In this video, I wanna show about vertical roller pre-grinder Vrmp 230. This is not pure vertical roller mill, but working principle wise is the same. Since it has no separator, it cannot maintain blades. It just grinds the material before feed the main mill. That's why it's called as pre-grinder. Let's go with nomenclature. What is the meaning of Vrpm 230? Vrp stands for vertical roller pre-grinder. M stands for mill. 230 stands for table diameter. 230 centimeters dia or 2300 mm dia.
After civil foundation, metal base align and level foundation carefully on liner before installing equipment. Installation on a proper level foundation may have an adverse effect on equipment performance or result in breakdown of equipment. Polish foundation surface carefully. If oil, grease or other foreign matter adheres to foundation surface, grind surface until foreign matter has been completely removed. Mill stand. Mill stand includes mill base. Upper surface of mill stand contains an opening for discharge of ground material. And reduction gear. Reduction gear is nothing but a gearbox. Reduction gear is a planetary gear with trussed roller bearings. Main motor, coupling, cast steel mill disc, otherwise table, high chrome cast iron liners, retainer plate, retainer bolts, lock plate, close plate, table liner segments and table. The mill table is directly connected to the output shaft of the direct transmission reduction gear. The upper surface of the table is fitted with table liner segments constructed of a special wear resistant cast steel and held in place with a retainer ring. The table liner is divided into segments for ease of handling. Size permits removal and insertion through the inspection port. A scraping paddle is installed below the table. The paddle is driven by rotation of the table. Lower housing device, air inlet, discharge outlet, hydraulic cover, hydraulic loading system. Pressure required for grinding is transmitted from the hydraulic cylinder to the roller and then to the raw material. Grinding performance varies depending on the amount of hydraulic pressure applied to the roller. Compressive force of the roller can be varied by changing the initial compressive force of the hydraulic cylinder. The initial pressure setting of hydraulic cylinder may be changed easily by means of the pressure switch in the hydraulic unit. Maximum hydraulic cylinder pressure 135 kg per cm square and maximum hydraulic cylinder pressure 110 kg per cm square. The relationship between initial pressure setting of a hydraulic cylinder and compressive force of the roller is as already shown. You can see in the picture. Hydraulic cylinder pressure minimum 70, maximum 136. Cylinder compressive force minimum 66,400 kgs to 1,28,650 kgs and roller compressive force 1,01,900 kgs to 1,88,200 kgs. Roller compressive force 260 kg per cm square to 480, maximum 480 kg per cm square. Roller system: grinding rollers fitted with rocker arm, fixing on the table, bolting, rollers. The grinding rollers are also made of special wear resistance cast steel. Grinding force is provided to rollers from above by a hydraulic cylinder. Each roller is supported and rotated by two bearings. Bearings lubrication is provided by a forced lubrication oil bath. Roller shaft: radial bearings of roller shaft are lubricated by a forced lubrication oil bath. Completely replace oil when necessary. Swing out, swing in, lock pin, retainer fix, bolting. It is total arrangement overview. Upper housing device, connected lower shell cover, center discharge chute, upper shell, all together fixed with bolting. Accumulator: initial pressure setting for accumulator is 65 kg per cm square. If gas pressure falls below this value, recharge until accumulator pressure stabilizes at 65 kg per cm square. It acts like a shock absorber, so that any sudden shocks comes in the mill, it takes it, so that the roller will not get affected. Mechanical maintenance platform: startup. After installation, start mill for the first time without charging feed and check direction of the rotation. Table should rotate in a clockwise direction as seen from the top. When mill rotates has reached the correct speed, begin feed. Initial feed volume should be somewhat smaller than normal. Intermittent feed must be avoided as this may cause mill vibration. Causes: clinker should not be fed directly from clinker cooler to the VRPM, bypassing clinker storage, as occasionally excessive temperature of clinker cannot be ruled out. The average clinker temperature should be 100 degrees centigrade and should not exceed 120 degrees centigrade in any case. Confirm that ground metal is actually being discharged from the discharge outlet. An excessively small discharge volume indicates that mill is not operating properly. In this case, measures must be taken to improve operating conditions to ensure satisfactory performance. Confirm that rollers are provided an sufficient compressive force. After completing the above procedure, confirm the following: the mill is rotating at the specific speed. Second one, that no ground metal is leaking from any part of the mill. Third one, the roller seal is being provided by the fan, that exhaust fan for air is operating properly. Shutdown: before stopping mill, continue operation of mill for several minutes until no feed material remains within the mill. Clinker feed falls on the center of the rotating table, where centrifugal force dissipates it into the gap between the table and the segments and rollers. Hydraulic cylinders provide the rollers with the comprehensive force required for grinding. The ground material is forced out over the rim of the table and falls to the base of the mill, where it is scraped toward the discharge outlet by a paddle installed under the table and discharged by a discharge outlet. When properly adjusted, the mill runs smoothly and silently regardless of feed volume. However, Weakening of roller pressure due to excessive wear of grinding parts or poor adjustment may result in vibration. In this case, readjustment is required. Further, a pieces of iron contained in the raw material feed may result in damage to the mill. A magnetic separator should be used to remove such foreign matters from the feed before they enters the mill.